We're going over the review sheet today. So the first problems we're looking at are these two here, 1 and 2. So number 1, 2 to the 2x plus 15 equals 8 to the x minus 7. Well, the first thing we want to do with this problem here is to get the bases to be the same. So we need to rewrite 8 as 2 to a power. Well, 2 to what power is 8? 3. And we could use a calculator if we wanted to check this, because 2 to the second power is 4. 2 to the third is indeed 8. So we would rewrite 8 as 2 to the third power, because again, we want the bases to be the same. Now on the left-hand side, it's still 2 to the 2x plus 15. Now here we would distribute the 3. 3 times x is 3x. 3 times negative 7 is negative 21. And with these here, our whole goal in solving is to first get the bases to be the same. Because once we have the bases the same, it means the exponents have to be equal. So our 2x plus 15 is going to equal 3x minus 21. Questions on this here? Now we just need to solve for the value of x. Well, there are many different things we can do. First, I'm going to subtract 2x from both sides. Because our 2x minus 2x will cancel, leaving us with 15 is equal to. That's kind of why I subtracted the 2x, because 3x minus 2x is just x. And the last thing we need to do to get x by itself is 2. So x is equal to 36. And that's it. Questions on this here? Are you ready for the next one? Okay. Now this is not a method that will always work. It will work on this test, but it's not something that always works. But a good way to determine if we need to get the bases to be the same, and if it's possible to get the bases to be the same, is if there's variables in both exponents. Because we had 2x plus 15 in 1, x minus 7 in 1. Okay, we're going to need to get the bases to be the same. It is possible to solve these without getting the bases to be the same, but we really haven't covered it, / it makes it harder. Now, 512 to the 5x minus 1 is equal to 1 over 8 to the negative 4 minus x. Well, we can move the 8 from the bottom of the fraction to the top. It just makes our exponent negative. Since there wasn't an exponent written next to the 8, it's just going to be to the negative 1. Now, it would be nice if we could rewrite 512 as 8 to a power, and it actually works out to be 8 to the 8 to the 6th.
To the 4th. To the 3rd.
Yep, 8 to the 3rd. Now by doing this, we do get the bases to both be 8, but before we can set the exponents equal to each other, we do need to simplify this a little bit, because our powers of powers multiply. So we'd multiply 5x minus 1 by 3, giving us 15x minus 3. And then we would multiply a negative 4 minus x by negative 1, giving us 4 plus x. And since the bases are the same, the exponents have to be equal. Questions on this here? What's the first thing we can do in solving for x? Subtract x, telling us 14x minus 3 is equal to 4. Next thing we can do is add 3. Add 3 to both sides. And if we add 3 to both sides, we have 14x is equal to 7. And last but not least, we can almost 14, because we want the x by itself. And 7 over 14 is 1/2. And that is it. Now, both of these do work out to be nice numbers, so these are actually our final answers. Questions on this here? We ready for the next one? E to the 4x plus 7 is equal to e to the 6x minus 35. Well, the bases are both e, yes? But are they still the same?
Yeah.
Yeah. So it's just telling us 4x plus 7 is equal to
6x minus 35.
Mm-hmm. Now the first thing we can do is, yes, we can minus 4x from both sides, telling us 7 is equal to 2x minus 35, 2x minus 35. Then we can add 35 to both sides, which will tell us that 2x is equal to 42. Yes. And last but not least, divide both sides by 2, telling us x is 21. That's it. Questions on this here? Questions on anything we've done so far? All right. We're going to look at the next one. Yes? Yeah. I'm just messing with the line so that y'all can at least see every now and then if you want to look out. Now, the next one's a little bit different, yes? Because we actually have addition, subtraction, we have multiplication. We don't just have two numbers, two exponents. So the first thing we need to do is to get the variable, or well, the term with the variable and the exponent by itself. So what can we do first? We need to move the 2 and the 7, because the minus 7. So we want to do addition, subtraction first, so we would add 7 first, telling us 2e to the x is equal to 12. So we move the 7. Now we need to move the 2. So we would divide by 2. Telling us e to the x is equal to 6. Questions on how we got to this here? Get ready for the next step. So now that the term with the variable and the exponent is by itself e to the x, we need to get that x out of the exponent. And we can do that by applying a logarithm, specifically the natural log. Because our ln undoes e, because ln of e to the x is just x. Now, is natural log of 6 a nice number? And it is. Ln of 6 is not a nice number. The only time the natural log will be a nice number is if the term inside of it is either e or 1. Because log of 1, natural log of 1 is 0. Log, no matter what the base of 1 is always going to be 0. So here that's not a nice number, so x is equal to the natural log of 6. So if we have e to a power, we're just going to leave it as e to a power. If we have log and a base or natural log and something inside that's not 1, that doesn't reduce nicely, leave it. I'm not going to make you type those in every single time. Okay? So that is the final answer. X equals the natural log of 6. Questions on this here? And hopefully that will save y'all some time in solving. Especially, we'll come back to number 5 in a second. If we look at 6, We have 7 to the x is equal to 3, yes? Well, our term with the variable and the exponents by itself are 7 to the x, yes? So what do I need to apply to both sides to get the x, the exponent?
Just log.
Base?
10.
Not 10.
Oh, 7.
7. Because we need the base and what's inside the log to be the same. Because the x would come out of the exponent. And log base 7 of 7 reduces to 1. So the log base 7 of 7 to the x is just x. The other side is log base 7 to 3. Because the only way that would reduce nicely, log base 7 to 3, is if the 3, we could rewrite as 7 to a power. So 749 going on up. Otherwise, it's going to be an ugly decimal. The only other way that would work out nicely is if it was log base 7 of 1. Then it would be 0. But we have this here. And that's actually the final answer. So that's kind of nice, yes? Let's look at 5. We do have to do something first. We got to get that e by itself. So the first thing we can do is what? Subtract 9. We need to get that to the other side. So we have 6e to the 2x plus 1 equals 6. What would we do next? Divide by 6. Telling us e to the 2x plus 1 is equal to 1. Questions on this so far? Now, the next thing we're going to do is apply the log, and specifically the natural log to both sides. And we do this because the natural log's base is e, so our ln of e to the 2x plus 1 is 2x plus 1. Now, for the most case, the natural log of a number is going to be an ugly number, yes? Natural log of 1 is 0. This is one of the few times it does reduce. I do specifically have in the instructions that they will reduce. The first part of the test will reduce to nice numbers. The rest may not. And if it doesn't, leave it as we did for number 7 or number 6. Leave it in terms of logs. If it does reduce, like number 5, solve it. We would subtract 1. Telling us 2x is equal to. And lastly, divide by 2. That's it. Questions on this here? We're real good with these so far. All right. Log 11 to the 6x plus 2 is equal to 38. Well, we don't have to add or subtract because the number with the variable and the exponent is already by itself, yes? So we'll need to apply a log to both sides. Log base what? 11. Because our log base 11 of 11 to the 6x plus 2 is 6x plus 2. And the other side will be log base 11 to 38. Now we just need to solve for x, yes? And I will tell you log base 11 to 38 is not going to reduce nicely. Well, the first thing we can do is subtract 2. Telling us 6x is equal to is x by itself? So we would need to by 6. That's it.
No.
Yeah. Questions on this here? We're ready for the next one. Next one's a little bit different. There are two logs, yes? On either side. Are they the same log? Yeah. Now, if we wanted to get rid of the natural log, we would put it to the base of what? E, because e to the ln would, leaving us with,
3x plus 2 equals 4x minus 5.
exactly. Because we'd have to put the other side to the base e, well, it and ln would cancel, leaving us 4x minus 5. If there's a log on either side and nothing else, there's no other addition or subtraction outside the log, log equals log and they're the same log, set what's inside of them equal to each other, and then solve for the value of x. What would we do first? We can add 5. Minus 3x plus 7 is equal to, then we would subtract 3x, which will tell us x is equal to, x is equal to 7, or 7 is equal to x. I normally flip it to keep x on the left, but both are the same thing. That's the nice thing about equality. Questions on this here? Now, one thing that is nice is if you do get a single answer on these, that's going to most likely that will be the correct answer. If you get more than one, check and make sure that we do not have a negative number inside the logarithm, as we cannot have negative or 0 in the logarithm. Not plugging it in, but 3x plus 2, so in this case 3 times 7 plus 2, this value cannot be negative or 0. Well, 3 times 7 is 21 plus 2 is 23. That's not negative or 0, so that works. Because if our value of x causes 3x plus 2 or 4x minus 5 to become negative or 0, we have to throw it out. Questions on this here? Let's look at the next one. Log of 12x minus 9 is equal to log of 3x. These are the same, yes? So 12x minus 9 is equal to 3x. Since they're the same log, one of them on either side, equal to each other, then what's inside has to be equal. Now we just need to solve for x, yes? Yes, we can minus 3x from both sides, which will tell us that 9x minus 9 is equal to 0, yes? Now, if we wanted to at this point, we could graph it, or we can go on and solve it. Our next step would be to add 9. Minus 9x is equal to, and lastly, we would. Again, we could plug it back in. 3 times 1 is 3. And that's for our 3x over here. So that works and gives us a positive. Our 12 times 1 minus 9, I'm just plugging it back in. 12 times 1 is 12. Minus 9 is 3. They're both positive and not 0. So they work. Questions on this here? Let's look at the next one. Well, the logs are both the same. So that means what's inside has to be equal. So x squared minus x minus 6 is equal to negative x. Now, since we do have an x squared term, we do need to try to get this equal to 0. So we can add x to both sides. Because on the right side, negative x plus x do simplify out to 0, yes? On the other side, we still have our x squared, negative x plus x is also 0. It works out our x terms. Those middle terms do simplify in both cases. Now, I think y'all want to graph this because I think at this point y'all like graphing, especially quadratics. They're a little bit nicer than factoring. So we could say x squared minus 6. Graph. Does that give us two nice solutions? It does cross at two places, yes. But it does not give us nice numbers. It doesn't cross at a nice integer. Now to solve this, because there's no middle term, we can add 6 to both sides. Telling us x squared is equal to 6. And the reason we're doing this is the square root method. Because if we don't have a middle term, we can do the square root method. I think y'all somewhat remember doing this. If we don't have an x term, we can get the x squared by itself, the number on the other side, and square root both sides. Now, I'm going to write this out a little bit, because we will get that x is equal to the square root of 6. But x is also equal to the negative square root of 6. We normally write it as plus or minus, but we do have both. Yes?
So, on the test, is it fine if we write it like that?
It is. It is fine if you write it as plus or minus, but again, since we do have 2, there's a good chance we'll need to check and make sure that they do work.
No.
They both work. Now, I'm going to do this a little bit easier, because the one way we can do it is I can rewrite it out as log base 2, parentheses. We'll just use the positive square root of 6 first. And I could write out, I'll show you here, because we could say log base 2 of square root of 6 squared minus square root of 6 minus 6 is equal to log base 2 of negative square root of 6. And we could write this out for each and every single one. But the key is what? That what's inside the log cannot be negative or, not positive, but 0. So we're saying that x squared minus x minus 6 and negative x cannot be 0. I'm not so much focused on the fact of the log base 2 and that part. I just want to make sure that neither one of those expressions becomes negative or 0. So instead of having to write the whole thing out, let's just focus on this part here. So if we do the square root of 6, so it'd be the square root of 6 squared minus square root of 6 minus 6. And the other one is negative square root of 6. So we good with this here so far. Now the easier one of the two is the one on the right. Negative square root of 6 is negative square root of 6. Is that negative? So what do we know about the positive square root of 6? We can't use it because it turned it into a negative term. Now, we could do this in a calculator, parentheses, second square root 6 squared minus second square root 6 minus 6 is negative square root of 6. So both of them, even though it's not so much the square root of 6, it's the fact that it is negative. So when x is positive square root of 6, when we plug it back into each expression, it gives us a negative number. So that's why we threw it out. Now if we check the negative case, so negative square root of 6 squared minus negative square root of 6 minus 6. And our other is negative square root of 6. Negative square root of 6. The negative and negative make a, so it's the square root of 6. And it works out if we plug the other one in, it actually works out to be positive square root of 6. Are both of those positive and not 0? Yes. So the one that works in this case is actually x equals negative square root of 6. If that makes sense. And again, I set this one up so that x equals negative square root of 6 was the correct answer. It's not always going to be the case that the negative solution gets thrown out immediately. On the test, that's probably going to be the case. But I wanted us to see one where it actually, the solution was negative, not positive. Does that make sense? Yeah. But again, doing this here like we did with the checking, instead of trying to type the whole thing in or write the whole thing out, we're just trying to see what's going to make what's inside each log be negative. And those are not going to work. We good with that there? And most of the time, especially if there's one like this here, negative x, the single term, use it to check. It doesn't matter if the other one was positive. If one of them gives us a negative or 0 inside the log, doesn't matter what the rest of them do. It doesn't work. Does that make sense? So let's look at these next ones here. Number 11, log base 7 of 4x plus 9 is equal to 2. Log is by itself, and we only have one of them. Now we use logs to get variables out of exponents. Now we're going to put this as an exponent to get rid of the log. Now what are we going to put both sides to the base of? It's not going to be 10, but 7. Because we're going to use the base of the log to get rid of it. Now if it had just been log of 4x plus 9, we didn't have a base specifically written, it would be 10. Now here the 7 and log base 7 will cancel, leaving us with 7 squared. Yep. Is 7 squared a nice number?
Yes.
7 times 7 is?
18.
Almost.
19. 14? Oh, you said close. I was even close.
7 times 7 is 49. 7 squared. Now we just need to solve for x. And the first thing we can do is minus 9. Because that'll leave us with 4x is equal to 40. And lastly, we would minus x is equal to, gave us a nice number. That works out. If it works out and simplifies nicely, simplify it. If it doesn't, leave it in exponential or logarithmic form. Does that make sense? Let's look at the next one. Is the log by itself? Natural log of 6x minus 2 is by itself. There's nothing being added to it or subtracted from it or divided or multiplied. So we need to put both sides to a base. What's our base? E. Ln is E. Because our E to the ln will cancel, leaving us with 6. E to the 7th. Is e to the 7th a nice number? No. No. E is irrational. E is an irrational number, and no matter how many times we multiply it by itself, it's still going to be irrational. It's not going to magically become rational. So now we just need to solve for x. We're going to leave it as e to the 7th. The next thing we'll do is add 2. Because since it's minus 2, we would indeed add 2. Now if it had been 6x plus 2, we would indeed subtract 2. Is x by itself?
Divide by 6.
Mm-hmm. So x is equal to e to the 7th plus 2 over 6. And that's it. Questions on this here? Be ready for the next two. Log base 9 of 2x plus 7 equals 2 is the log by itself. Yeah. Because the 2x plus 7 is contained inside the log, so we can't do anything with it at this point. So it is by itself. So we're going to put both sides to the base of what? 9. Because our 9 to the log base 9 is going to cancel, leaving us with second power, which is 81. Now we can rewrite it as 9 squared, or we can type it in the calculator and see that it's 81. Yeah, because we could rewrite it as 9 squared, kind of as we did here, 7 squared, then we'll rewrite it as 49. Or I can just take that step out and just rewrite it as 81. Now the next thing we'll do is subtract 7. Telling us 2x is equal to 74. And lastly, we will now for the most part, we can use the 30XS are yellow calculators for all this here, because there's nothing so far that we've actually needed the graphing calculator for. And especially with some of our division on the ones that work always, even if it's a fraction, 13/17, that's still nicer than our irrational numbers. Does that make sense? But that's it, 37. Questions on 13 before we look at 14. The natural log is by itself, yes?
No.
No, what's with it? Because we have the 6x inside, but we also have the what? The minus 4. Yes? We have to get it to the other side first. So we would add 4. Which will tell us ln of 19. Yep. Our 15 plus 4 would give us 19. Questions? Now that the natural log is by itself, we're going to put both sides to the base of e. E and ln will cancel. Telling us 6x is equal to e to the, solve for x. Divide those by 6. Telling us x is equal to e to the 19th over questions on this here. You ready for the last two that we're going to do today? You're good. Oh, apparently I jumped a few slides. Okay. Now the next two we're going to look at are these here. Now we do have two logs, but we also have a number. So we can't just say that what's inside is equal because of the 2 on 15 and the 3 on 16. Whenever we have two logs being added together, I can rewrite them as a single log, and what's inside is being multiplied together. So we can rewrite log base 2 of x plus 4 plus log base 2 of x plus 1 equals 2 as log base 2 of x plus 4 times x plus 1 is equal to 2. Now we're going to solve it exactly like we did the last one. But this time we're going to put both sides to the base of 2. Because our 2 to the log base 2 will cancel, leaving us with equals 2 to the second or 4. Because we could rewrite it as 2 to the second. You could rewrite it as 4 now. We will switch it over to 4 at some point. Questions? Now the left-hand side, we will have to distribute this. X times x is, x times 1 is plus x. 4 times x is plus 4x, and 4 times 1 is plus 4. Now we will combine like terms because our x plus 4x is 5x. And we get this here. Questions on how we got to x squared plus 5x plus 4 is equal to 4. Now at this point we need to get this equal to 0 because we have an x squared and x term. So we can subtract 4. Tell me x squared plus 5x is equal to 0 because on the other side 4 minus 4 is 0. Incidentally, 4 minus 4 is 0. So we have x squared plus 5x equals 0. Well, we can graph it, we can factor it, we can quadratic formula it. I have a feeling I would prefer to just graph. And all the ones on the test are graphable and are nice. Because we do get two nice solutions here. Their solutions are -5 and 0. So the two solutions for this are is x is equal to -5 and x is equal to 0. Now, since we did get two solutions, we need to check them, make sure they work. It could be that both work, it could be that one works, and on the test, it will not be the case that neither works. Now, we could do -5 first. -5 plus 4 is -1. Do we even need to really try the other side with -5? No, because if one doesn't work, the other one's not going to work. And if I did try this, -5 plus 1 gives us -4. Okay. On the test, even if one of them doesn't work and you know one of them's not going to work, still go on and give me that answer. I'd still like to see both. All you got to do is cross the one out. Does that make sense? Now, if we try it with 0, I'm going to change colors. 0 plus 4 is 4. 0 plus 1 is, and when we plug 0, the two values that we get are both non-negative, non-zero. They're both positive numbers that aren't 0. So x equals 0 is our solution. Questions on this here? We ready for the last one we're going to do today? Since we have two logs that are being added together, we can rewrite them as a single log with what's inside being multiplied. Then we'd put both sides to the base of 2. As our 2 to log base 2 will cancel, leaving us with x times 2 is equal to 2 to the third. But 2 to the third will reduce to 8. Now at this point, we do need to distribute. X times x is x squared. X times -2 is -2x. Is equal to 8. And again, just like the last one, we do need to get this equal to 0. X squared minus 2x minus 8 equals 0. I'm going to go on and graph it. Squared minus 2 minus 8. Graph. We do see it crosses the x-axis at 2 points. -2 and 4. So we have these two solutions here. Now our two spots are x and x minus 2. Now when x is -2, for one of them, but they're just single x, when I plug -2 in, it's just -2, yes? So is that one going to work? No. -2 minus 2 is -4, so it definitely doesn't work. If we do this with 4, with our x, it would just be 4. 4 minus 2 is 2. Both are positive, not 0, so it would just be x is equal to 4. And on the test, I believe there should be only one that's like these last two. Okay. Questions on this so far? And again, we will finish this up tomorrow. Your test will be Wednesday. And I do believe you'll be able to finish this in one day. Because it is taking me longer to actually go through it and explain it than it is for y'all to actually solve this. I think most of y'all could have solved this before I finished explaining one of them with most of these here.